Problem number 19. Let's see this. Let's see what we can do here. All right. So the first step is trying to figure out the axis of symmetry. This is the one where we are finding the derivative, right? So to find the derivative, I take the exponent and I multiply it times the coefficient. 2 times 3 is? Yeah, so f prime of x is equal to 6x. The reason I took x is I took 1 away from the 2, right? 2 minus 1 is 1. That's why I'm left with 1x. Well, there's a 1 here, right? And if I take this 1 times 2, I get 2, right? But if I take 1 away from the 1, then I get none, right? And x to the 0 is equal to 1, right? And 1 times 2 is still 2, right? Okay. So that's how we do the derivative. Okay? And remember, there's an x to the 0 here, where we take this 0 and multiply it by the 8, which you get 0. You take 1 away from that 0, you get negative 1, right? So 1 over x. But 0 times 1 over x is still 0, right? So that's why it goes away. That's why the last number goes away. This is what we call the derivative. Now, I also told you that when we do this, this is kind of like 2a plus b, right? Whereas ax squared plus bx plus c is the polynomial, right? And so, if you think about it, this is the way the book tells you. Just do this, right? Well, all they're doing to do that is finding the derivative, right? We talked about that yesterday, about the derivative. The derivative of this function, right? Because it's smiling, right? Because the front of it's positive. So we know it's smiling. Well, we could look at this function like right here. That'd be a positive slope. We could look at it right here. Right? I mean, if you want, I'm just kind of giving you a good understanding. Right? So right here, it's a negative slope. Here, it's a positive slope, right? And I could continue to change these anywhere on the slope, right? It just gets more positive, more negative. Or I can come down to where it changes from positive to negative, right? The bottommost point, in this case, the minimum, right? The minimum, right, value. And that minimum value is when the slope is equal to 0, right? Right? So the instantaneous change. Remember? Instantaneous change is the difference in y over the difference in x. That's the instantaneous change. That's the derivative. Right? Well, that's also the slope. And so what we do is when we take the first derivative, we just set that equal to the slope we're looking for. The slope we're looking for is 0. Right? Because that's the easy slope to find. That's the slope at the bottom, where the axis of symmetry is. Right? Where if we take this and fold it onto itself, right? That's where the axis of sym is. Okay? So as long as we can find this value for x, then we'll plug it back in to find the value for y. Does that make sense? But first we've got to find the value for x. And so we just do the math. Minus 2 minus 2. I get 6x is equal to negative 2. Right? And then divide by 6, divide by 6. I get x is equal to negative 2, 6. I reduce that to x is equal to negative 1/3. And that is my axis of sim.
What's up with the minus 1x up on the unnext?
Minus 1.
Yeah,
Up here?
Yeah, that.
Well, when you're doing the derivative, to do the derivative properly, you take the exponent times the coefficient and then subtract 1 from the exponent. And that's how we get just 1x. You had 2 x's, right? You had x times x, and now you have just an x.
And that's how the one at the bottom makes 0.
Exactly. Because there's no x's there. But there is. But there is.
Yeah.
But there is. It's an illusion. Right? Okay? So that's the axis of symmetry. Let's try this. Can I do that? You click on that, Sarah?
Click on what?
This thing?
Yeah.
Shouldn't that make me another page?
That's a good question.
It should, shouldn't it?
From what I see, it's only highlighting that one page.
And we get a new one.
You can hold it on.
Huh?
Try to hold it. Did you try holding it on there?
How about file?
Nothing, type keyword.
Insert.
New page.
New page. BAM!
Oh, there you go.
What? Alright, so we have to remember one thing. We started with, back to the pin. We started with f of x was equal to what? 3x squared
Plus 2x
plus 2x minus 8. Right? That's what we started with. Then we found f prime of x equal to 0, right? And that was x is equal to
negative 1/3.
-1/3. And that was the axis of sim. Right? And so that was 1. And now we got to move to step 2. And if you remember what step 2 was, it was, well, find f of the axis. Okay? F of the axis. Is this thing on? Yeah? Okay? That just means I find f of negative 1/3. Which means I have 3 times x squared plus 2 times x minus 8. And then I plug in negative 1/3. Alright? And then I find the values. What's 1/3 squared? Or negative 1/3 squared? Very good. 1/9. Times 3. Well, 3 goes into 9 how many times?
2.
How many? 3. Okay? And so what is 2 times negative 1/3? Very good. Negative 2/3. Okay? Now, so that changes this to minus 2/3, yeah? And then plus, or, plus, minus 8, yeah? Okay? And these should always be halves. One's bigger, twice as big as the other. Always. One's twice as big as the other. Always. If it's not, you did something wrong. Okay? And 2/3 is twice as big as 1/3, right? And when I take the difference of them, cuts that in half, right? So it's going to be negative 1/3, right? Negative 1/3. 1/3 minus 2/3, negative 1/3, minus 8. Now at this point in the game, you should know that a minus, right? If I owe 1/3 and I owe another 8, I owe 8 1/3, right? At this point in the game, it shouldn't be hard to figure out. This is 8 1/3. Okay, so that's what f of negative 1/3 is equal to. So what's that telling us? Well, that's telling us the vertex is this number, negative 1/3, and this number, 8 1/3, negative 8 1/3. Okay, and that's where the vertex is. Okay? So we go into File or Insert, New Page. Okay? Do we need to go back to that page real quick? Wow, there it is. So that way I don't get you guys caught up.
What's up? Why would you do the minus 1/3 for the 8? What about the other 2/3?
Well, what's 1/3 minus 2/3?
1/3.
No, negative 1/3.
Negative 1/3, yeah.
What's negative 1/3 minus 8?
Negative 8 1/3.
And that's what I got it.
Alright. I'll do that.
No problem. It's good questions. I'm sure you're not the only one wondering it. Okay, so we good? Moving on to number 3. Alright, step 3. Do we remember what step 3 was? Remember, step 1 was f of x is prime is equal to 0, and that's the axis, right? Step 2 was plugging in f of the axis, right? And that gave us the vertex, right? And step 3, huh? F of 0. F of 0. Okay? And what that means is this. What was f of x? Was it 3x squared?
Oh yeah, 3x squared plus 2x minus 8.
Plus 2x minus 8?
Yes.
Okay. And so, to find f of 0, right? What's going to happen here is they take 3x squared plus 2x minus 8. Then I plug in the zeros. What's 0 squared? What's 0 times 3? Yeah. So that's just 0. What's 2 times 0? Yeah, that's just 0 minus 8. Right? What's 0 plus 0?
0.
Man, you guys are on a roll. Okay? So what's 0 minus 8? Woo! We got it. So f of 0 is equal to, and remember I said f of 0 was equal to c, right? When ax squared plus bx plus c was your quadratic, right? So it's always going to be this number. Does that make sense? It's the easiest thing to think about.
Wait, so the x is always going to be 0?
No. When x is 0,
alright.
the answer is always c.
Alright.
Okay? Whatever that last number is, right? This is where, now think about it. If x is 0, right? If x is 0, then the answer is going to be somewhere on this, right? What's this called? The y-axis. So this is the y-intercept when x is 0. This is your y-intercept. Okay?
Alright.
That make sense? All right. So that's step 3. Pretty simple, yeah? All right. Okay, step 4. Okay. So we know that step 1 was f of x prime is equal to 0, and that's the axis. We know that step 2 was f of the axis is equal to the vertex. Okay. We know that step 3 is f of 0 is equal to c. Right? So what's step 4? F of 2 times the axis. So 2 times the axis. So F, let me write that better. 2 times the axis is equal to C. Okay? It's equal to C. And this is our check method. Because what this should do is it should produce a mirror. Right? If it doesn't equal C, we did something wrong. Our axis of symmetry is wrong. You got it? Okay? So, what is f of x again?
3x squared plus 2x minus 8.
3x2 squared plus 2, x minus 8. Okay? So, what was our axis? Our axis was equal to negative 1/3, right? So we need to plug that in. So f of 2 times negative 1/3. Well, what is f of 2 times negative 1/3?
6.
Negative 2/3, right?
What does that say?
Huh?
Number 1.
Number 1 is the f prime of x is the axis. And f prime of x equal to 0 is what we call the axis. That was our first step. All right, I'm just writing these over and over and over. Why? Yes. Okay? Alright. Help me out here. What do I do now? Once I plug this in, right? 3 times x squared plus 2 times x minus 8. Then I'm just going to plug in negative 2/3. Negative 2/3. Okay? And what is 2/3 squared?
4
Good. 4/9, because it becomes positive, correct? What is 2 times negative 2/3? Negative, right? Because a positive and a negative make a negative. 2 times 2 is 4/3, right? Okay. Minus 8. Well, can this 3 cancel out the 9? Sure. So, boom, boom. So I get 4/3, right? Minus 4/3. Hello. Minus 8. What happens to those 4/3? Right? So, f of negative 2/3 is equal to negative 8, correct? So that means that we have another point at negative 2/3 and negative 8, correct? So let's take a look at all these points that we have. Alright, insert a new page. So what was the first point? What was our vertex?
Negative 1/3, negative 8 and 4.
Negative 1/3 and and what?
-8 1/3.
And -8 1/3. Okay? What was our y-intercept?
What?
You know, when x was 0.
Oh, -8.
Okay? And then, what was our other, and this is the funny thing, that they don't have a name for this point. They didn't even teach you to find this point in the book. Freaking kidding me? You need 3 good points to make a curve. 2 points make a line. You need 3 good points. And when I say good points, I mean good points. I mean good points. Not the points that they ask you, just make up a point, put in a number, figure it out. No, that's not a good point. Might come over here, might be over there, it might not exist. Okay? So, a good point is a symmetrical point. Okay? The symmetrical point was the next point we found. I call it the point of symmetry. Right? I call it the point of symmetry. Okay, what was that point? Remember, because that was 2 of these. It was -2 thirds. What was the other? -8. Because that's what it was supposed to be, right? That's the key here. It should be at the same spot. Okay? Now I got to graph this. This is fun. This is the fun part, right? How do I graph this? Well, a lot of you get confused. So you're like, okay, I make this graph, okay? So I make this, it's a beautiful graph, right? And then I'm like, 1, 2, 3, 4, 5. And I'm like, 1, 2, 3, 4, 5. I'm like, 1, 2, 3, 4, 5. And I'm like, 1, 2, 3, 4, 5. And I'm like, whatever, okay? Because these don't have to be 1s and 2s and 3s and 4s and 5s. I mean, that's nice. And then sometimes it's not nice. Okay? Make it what you need it to be. We need to go to -8 and -8 1/3. So go by 2s. Okay? -2, -4, -6, -8, -10. Right? What else do I need? I need x's, right? But these x's are negative, yeah? And 0. So could I just go 0, -1/3? Right? -2 thirds? What would that one be? -1? Right? Does that make sense? Okay? So now I know where my points are. Kind of. My vertex is at -1/3 and -8 1/3. So it's a little bit off, right? It's like in there. Does that make sense? And then my other one's 0, -8. Well, it's right there. My other one is -2 thirds and -8. So it's about right there. And see how these go like this? Right? Not a very good graph, is it? Doesn't tell you a lot. It does tell you that it's a parabola. It does graph it. Right? And that comes next week. Well, not next week. Yeah, maybe next week. We're going to talk about factoring and finding the zeros, right? And then the week after that, we're going to talk about quadratic formula. Remember how I said this is 4 steps plus 1? So the plus 1 is a quadratic formula. And the quadratic formula does this. It lets me go, okay, where is this going to go? And when I get there, where am I going to be?
Down.
Okay? That's what's coming. Okay? But for right now,